So this PPT I prepared, I think long back in year 2015, revised last year. This time I haven't added anything into it, so it is as it is. I prepared for the last year. So this PPT first talks about the uh, advantage of having a panel data regression. So I'm skipping this one because this we have already discussed. The outline we can say when we deal with the panel data regression model. So that panel data that work mainly consists in data management work, and after having a data management, we move on to the estimation. So as I given task to you, I gave you 3 Excel file and told you to make a panel data. So that one is a part of data management. And estimations comes after that when you have a panel data. So in a panel data regression model, we mainly focus on fixed effect model and random effect model. Okay. But to understand fully, first we estimate full regression model, then after fixed effect least square dummy variable, and after then we move on to the fixed effect and random effect model. So as we have discussed, for making a choice between fixed effect and random effect, we do Houseman test. So we'll discuss about that. Once we have made a choice, okay, we estimate the model, and after estimating the model, we do diagnosis test for heteroscedasticity, autocorrelation, contemporaneous autocorrelation, and after then we adopt remedial measures. So that's what we do in a panel data regression. So in a data management, as I told you, we generally we have different data file from different sources. So we require to merge that, and after merging, we require to bring that into a longitudinal format. So let's suppose that this one is the one example of data set. So here you are having particular informations for different countries over a period of time. So here it's a 1960 to 1970. So it is just a snapshot. So period mentioned on the top. In the first row, we are getting information about the year, and second one we are getting information about a particular variable for different years. So and so this format called a wide format, and generally we get data in such a format only, because data I have shared with you, that one is again in a wide form. So there you are having a cross sectional countries in a first column, and in the rest of the column you are having a values of a particular variable for different year. So this one is the wide form. For a panel data, we require to convert this wide form data into a long form data. We also call that one is a longitudinal form. So in a longitudinal form, looks like this. So in a first column, you are having a country. In a second column, you are having a years. And in a third column, you are having a values of a particular variable. So first few observations belong to a particular cross-sectional unit, and data for that cross-sectional unit given over a period of time. And here you are having a year variable in a order. So if time period starts with the 1960, so second observations, which one is the first observation of ith cross-sectional unit, contains value of first year, then second year, then third year, and so on. After then, second cross-sectional unit, values start, and that again start from the beginning year, and you will get value of that particular cross-sectional unit till year end. So this one is the longitudinal form data set. So our first task after merging the data set is to convert wide form data into a long form. Sometimes what we do, once we get our data onto Stata, we convert that into the long form, and we do merging later. So we will merge longitudinal form data with the longitudinal form data. These are the two commands for converting wide to long, and the second one is long to wide. So you require to use either one. So you are having a wide form data, then you have to convert that one into longitudinal form for a panel data estimation purpose. Sometimes we require to run a cross-sectional regression model using our panel data. So in that case, we convert longitudinal to wide form data. After then, once you have a panel data, then we tell Stata to consider particular variable as a cross-sectional variable or a cross-sectional unit, and particular variable as a year variable. So that called a declaration of data to be a panel data, and that we do with this particular command htset id here. And once you do that, Stata tells us whether our data set is balanced panel data or unbalanced panel data. Since in this course we are dealing with the balanced panel data set only, if in a case if you get a unbalanced panel data, we made our data set into a balanced panel data set. Rest few commands we use for plotting time series across cross-sectional unit and time, and plotting cross-sectional unit over a period of time. So these commands we use for mainly making few kinds of graphs. Times. After then, if you want to check the heterogeneity across country for a particular variable, then you use this command. Similarly, if you want to check the heterogeneity across year, then you can use these commands. So, and of course, before moving on to the regression model, we do some descriptive statistics. That means, as usually do in case of cross-sectional regression equation. So, I think that command is missed from here. So we use that one also. In a cross-sectional regression model, we simply type describe or summarize. Similarly, here we type xt summarize or describe, xt describe or xt summarize to get summary statistics of panel data set. Then after we move on to the regression, so first we estimate the pooled OLS. So command are here. So for pooled OLS, we do not need to add xt as a prefix. We directly go ln total serial is here log of total serial, ln GDP is log of GDP. Yeah, I will describe these variables when we work with the actual data set. So the data set I have shared with you that contains cereal, meat, and GDP. When we combine cereal and meat consumptions, we get total cereal consumption. So we'll talk about this particular concept in a little bit. So the first command is to get the pooled regression model. The second one is to get pooled robust estimates. And for getting that, I have used here cluster ID. Why I have used a cluster ID here, that we again will discuss when we do estimation. So I am not explaining that. Pooled FGLS again we can do. So that also called the population average regression model. We can discuss about this too. So here are the command written. I am explaining this to you. We may have to refer all these commands when you estimate panel data regression. After then, fixed effect random effects comes here. But as I told to you, we estimate fixed effect least square dummy variable also to make a comparison across 4 model: pooled, fixed effect, least square dummy, random, and fixed effect model. So this one is for fixed and random effect. Here some comparison are made between the fixed effect and random effect model. About almost all these things I have discussed with you. So just go through this. Let's talk about how we made a choice between the random and fixed effect model, which one is efficient when, which one is inefficient when, why Houseman test is not a sufficient condition for making a choice between random effect model and fixed effect model. So this we have discussed. We also have discussed the drawbacks of Houseman test in detail. Here I covered those things very briefly. So this one is the panel data regression model. This we will estimate today also. So YT in our case would be total cereal consumption, and XT would be the per capita GDP measured in terms of, per capita income measured in terms of per capita GDP purchasing power parity terms. So these are the explanation of that. These are the regression command. So first one is for pooled, second one is for fixed effect least square dummy variable. This one, let me write. This one I'm talking about. So this one is, so this one is for pooled, simple pooled regression model. I haven't used here a robust standard error. This one is the fixed effect least square dummy variable. Yeah. Again, without using robust standard error. Why it is so? Because this one is for cross-sectional damage, and this one is when I have also included time damage into a regression model. So this one is again fixed square, fixed effect least square dummy variable with time damage. So we can say with time damage. This X should be in a small letter. So always remember this should not be in a capital letter. This should be in a small letter everywhere. So XT regress one is, this one is for fixed effect as FE options given here. So this regression model, this particular regression model, one is the one-way fixed effect regression model. So when we read test book, we'll find a discussion of one-way and two-way fixed effect model. So when we do not include time domain into a fixed effect regression model. That's called a one-way fixed effect regression model. And when we include time damage, this become a two-way fixed effect model. So this one is the two-way fixed effect model. So this one is the basic difference. And this one is for random effect model. So in the random effect model, we may include cross-sectional dummy and time dummy also. So this one is without including cross-sectional and time damage. These commands are for Hosman test. So in a Hosman test, first we estimate fixed effect, store the result of fixed effect. So estimate fixed effect, store the result of fixed effect. Then after you run random effect, estimate the estimates of random effect using this command. And then after we run this command for getting Hosman result. This we can also use, but I always suggest to use this particular command with the option of sigma more here. After then, we test the random effect. So this one is the command Bruce-Pagan-Lagrange multiplier test for checking whether panel data consists random effect or not. The null hypothesis of this particular test is variance across entity is 0. That means there is no significant difference across unit. So if null hypothesis is rejected, then we can say there is no random effect. Otherwise, there should be a random effect. So variance across entity is 0. That means there is random. Then after we also test for time effect and fixed effect. For time effect is as usual testing time damage, all time damage using F statistics. They simultaneously test all time damage. In case of testing time effect, and in case of testing fixed effect, you simultaneously test all cross-sectional damage equal to 0. And if null hypothesis rejected, you can say there is fixed effect. Similarly, in case of time effect, if null hypothesis rejected, you can say there is time effect. After then, we do diagnosis test. We test for heteroscedasticity, test for serial correlation, we test for normality, we test for cross-sectional dependence, that also called a contemporaneous correlation. For that, there is a particular test which called Pisaron's cross-sectional dependent test. And contemporaneous correlations we define when you have error term of country I in time t is correlated with the error term in country j at time t. So we test contemporaneous correlation, and if you find a presence of contemporaneous correlation, we do and we adopt a remedial measure for that. If not, then okay. In presence of contemporaneous correlation, we get biased and inconsistent estimate, even with the fixed effect estimation. And because of that reason, this test becomes very important. So we test for that. This particular slide discusses various measures and we adopt in case of particular kind of problem. So I mean to say, when our regression model suffer with only heterozygosity problem, so in that case, if there is no autocorrelation, no endogeneity problem, so we rely on full regression model and remove heterozygosity just using VC robust option with the regression model. If there is heterozygosity and autocorrelation, then you use the second command, either with regress or XT regress with the option of cluster robust standard error. The third one is when first order autocorrelation only, new command is used for heterozygosity and autocorrelation, and new you may use when we have higher order of autocorrelation. The third one, XTGLS one, is in case of long panel. So you are not dealing with the long panel, so may skip this one. XTPC1 is again for
Sir,
a short
sir,
yes.
excuse me, sir.
Yes.
Sir, I think you were saying something for the last like 30 seconds or 1 minute, which got cut off. Like, could not hear.
Okay, let me. 30 seconds you are talking about. So, okay, let me restart again. I'm re-explaining this particular slides. So the first one you can use when you do not have any other problem apart from heterozygosity. So any other problem with our regression model. So that means when you do not have autocorrelation problem, we do not have endogeneity problem. So in that, or any other kind of problem. So in that case, we simply use pooled OLS, and for that we may use regression command or XT regression command. That hardly matter. But the one problem arises here when we use XT regression command and we do not give any option. Stata by default consider XT regression as a random effect regression model, and because of that reason we avoid using XT regression when we estimate pooled regression model. So better if you use only regression. So REGYX, then after comma VCE robust in case of when regression model suffer with only heterozygosity problem. The second one is when regression model suffer with both heterozygosity and first order autocorrelation. So that one is regression XT regress. Sorry, regression YX comma cluster option. Third one is when regression model suffer with autocorrelation and when regression model suffer with the first order autocorrelation. That was the AR1 given here, autoregressive one. So in that case, you may use XTREGAR command for estimating regression model. New way you can use when you are having both heterozygosity and higher order of autocorrelation. So new way you can use in a cross-sectional regression model also. And by the way, all first four commands we can use excluding STREGAR in case of cross-sectional regression model also. XTGLS one in the case of when you are having a long panel. So in this course, we are not discussing with the long panel. I'm not going to discuss this. As you read here, in the case of long panel, when you are having a heterozygosity, contemporaneous cross-sectional correlation, autocorrelation of first order, then you can use XTGLS command with the option of panel. In bracket, we identify our panel with the cross-sectional unit, and in the correlation in a correlation bracket, you have to mention the order of autocorrelation. So this XTGLS valid in a case of first order autocorrelation also. So that we may use when we work with the long panel data set. XTPS PCSC command one is again for a short panel. So when you are having a heteroscedasticity, contemporaneous cross-sectional correlation, autocorrelation of first order, we can use this particular command. Only problem with this command is this command takes a bit long time in giving results. So with a larger panel data set, that means larger panel, that means longer panel. It is the larger cross-sectional unit, we have to wait a bit to get a result with this particular command. XTSCCC1 is the best one. It takes care of everything, heteroscedasticity, autocorrelation of any order, and contemporaneously correlation problem. So I always recommend a student to use XTSCC command when regression models suffer with all these problems: heteroscedasticity, autocorrelation, and cross-sectional dependent problem. This is also called a contemporaneous autocorrelation. So these are the remedial measures that we generally adopt when we state regression model. And in last, some references are given. Cameron and Trivedi one is, I think, the best one when we work with the empirical exercises of panel data regression model. Apart from Cameron and Trivedi, Stock and Watson book. So we do find stata command there. We will find a good discussions on empirical things relating with the panel. So there are two Cameron and Trivedi. Already know about it. One deals with the theory, another deals with the stata command. We are using Cameron and Trivedi for stata command only in this year for this course. In a theory, and Cameron and Trivedi deals with the theory, also having a good discussion on panel data.
So your voice is breaking.
Rest are the articles, which again is a very useful article. I used a particular. Is it clear now? Probably because of internet problem my side. Hello.
Yes, sir, we can hear you. Yes, sir.
Can you hear me? I think. So is it clear now? Hello.
Yes, sir.
Okay, so okay, not present. Let me present my slide. Can we see this slide?
Yes, sir.
Okay, so I am talking about this particular reading. This reading I'm talking about. So I found this particular reading very important when I was doing my PhD. So I recommend you to also to go through this particular reading. After this, there is a one document that we can found from Princeton University. So that one is again a PPT presentation on panel data regression model. Some of the slides in here I use from that document only. So just type on Google panel data regression model, comma Princeton University. You'll get that document. The document is very famous. It's not very hard to get that one. So again, that will help you a lot for understanding panel data regression model, particularly the estimation part of panel data regression model. For a theoretical discussion, as since we have already covered this time, so Woodridge and Cameron and Trivedi. These two are good book. Baltagian book earlier considered as a popular reference reading on the panel data regression model. But in these days, we generally do not follow Baltagi just because the better textbooks are available, both in theory and empirical economics.
Sir, can you write down the name of the book that you mentioned?
Which one? Princeton University document?
No,
Hello?
sir, the one you just mentioned. The one you just mentioned.
They all are written here. Baltagi book, J. Badi Baltagi book, econometric analysis of panel data.
Oh, sir, I did not see it. Sorry.
Okay, so it's this one, the first one. The first one is the Baltagi one only. So earlier, this one is the popular reference reading on the panel data regression model. I remember when I started working on the panel data regression model, the professors recommended me this book only, Baltagi and Cameron and Trivedi. So at that time, Cameron and Trivedi was not available, I think, at JNU library. And initially, when we start reading Cameron and Trivedi, you find this particular book very difficult. Even the first one is also very difficult. It's not an easy. So somehow I arranged this book. Baltagi, we took a xerox of that, the entire book, okay, and tried to read few chapters. But so that was my experience with the Baltagi. Otherwise, these two books, Cameron and Trivedi and Woodridge book are enough. Woodridge one is the much better as compared to Baltagi and Cameron and Trivedi. So this time only I have gone through the entire chapters of Woodridge, which one is the chapter 10. Earlier I read a part of it. This time I read the entire chapter. Not only the chapter 10, for reading a chapter 10, we need to supplement chapter 7 also. So, already start discussion of panel data regression model from chapter 7 itself. In chapter 7, first they discussed about the pool regression, then they discussed about the bit on panel data regression model, and then already discussed chapter 10 for details on panel data regression model. So that's one. The Woodridge one is the, I think, in my opinion, one is the best book. After then, Cameron and Trivedi, and after reading a Cameron and Trivedi, we may supplement this Podesta one. And for empirical estimation, I am telling to you that one is Princeton University document that is also a PPT on panel data regression model. So I think this much are enough reading on the panel data, able to know each and everything, at least on the basic panel data regression model. For a advanced, we'll talk about that when we work with that. So this much from this PPT. I'm going to end this presentation, and then after we going to work with the data set that I shared with you.
Sir,
Yes.
sir, the commands that you mentioned, are they there in starts with data book?
Yes.
Okay, sir.
Each and every command are there in the book. Cameron and Trivedi, regression with this data. Even I will share this PPT slide, so don't worry about that. You will have a multiple copies of all these commands. So Cameron Trivedi one is the good book for empirical estimation thing. Microeconometric using data. So you use revised edition, which one is I think. So there are two editions of this book. One is the original one, original and the earlier one. The second one is the revised estimation. I recommend you to use revised edition. And you will get this particular books on LinkedIn and other book depository websites. So, I shared with you FO data set on cereal consumption, meat consumption, and World Bank data set on GDP. So let's open one. So I'm opening one data set. The CSV data set. So this one is meat consumption data set. So what information here you are having? We are having a domain code. So the first column, first row, one is the domain code. Then after you are having a domain, area code, area. In area you are having a, I think, country name. So the first start with the Afghanistan, and it goes on. Then after you are having an element 6451 is element code. The element is here, food supply quantity given in per capita, given in kg per capita per annum. Item code is 2943. Item is meat. Then after you are having a year code, year variable, unit, value. Flag is also given. Don't know what about it. Flag description. One is calculated data. So they start the all calculated data. So therefore have a particular methodology for calculating total meat consumption. So this one is the total meat consumption, which includes meat from poultry, goat, beef, pork, birds, and other meat. So in this, from this particular data set, what will be needed? Will be needed country code information, country name information, then after year information and value information. And we know this one is a per capita, per person, per annum variable. So what we do, we remove rest one. So we keep value, unit we also remove, year we will keep, year code we remove, meat we remove, item code we will be not needed, we will remove, element description will be not needed, element will be not needed. So what remains with us? That one is the area code that we may name country code. I renaming this one just for my convenience. Then after country, then year, I'm making this one in a small, and then
Sorry,
this one
can't
is
see
a
the
big.
presentation.
Oh, sorry, I'm not presenting that.
Yes, sir.
You have to remind me earlier.
Sorry, sir.
Starting presenting. Not presenting. In a little bit, that will start presenting. Still loading. Yeah, started. And now we can see. So what I did, I deleted all irrelevant information. So the relevant information in our case, one is country code. So that I renamed. Earlier it was region code. Country name was region, so I named that one is country. Then year, then meet. Meet one is earlier it was in values. I renamed that one as a meet. So look here, this one is the longitudinal data set. So when I downloaded from FO Stats, FO gave me this data set in a longitudinal format. Okay. So in this particular data set, you have nothing to do much. We require to import this one onto a data, and once you have done, save that data file. So I'm opening. I'm opening Stata 13 and importing. Let me save that data set first. So this one is data set. I'm saving this data set. So rename also. We rename save as first. Desktop. This one is panel lab. So I'm saving a folder that I have created. So this become a read. I'm saving this one in an Excel workbook. So this. So I open this data set. Open this data 13. What I need to do, I'm going to import the data set that I just saved, browse, then go on panel lab. So meet data set I saved. So I importing meet data set. So first row as a variable name, that's gone, and then save. So data has been imported here. So now we can see the data, our data. So this one is our data. The first one is the country code, country, year, and variable information. So save this one for making into that particular and saving this into that particular folder. First I have to change my directory. I go on to the data. Sorry, I will go on to the desktop. Panel lab one is the folder which I'm going to make my directory. So I click on to this. Copy folder path, and that becomes my directory. Now I save this one. Similarly, I will do with the serial consumption data set. The second CL3 file, that I shared with you, that one is for serial consumption. So again, you are having a different information here. So we will delete unnecessary informations that we are not going to use. So I deleted that one. Area code one is my country code. Area is one country, so I renaming all these. Element we are not going to use. So area element 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 code, element, item code, item one is the serial here. And in our case, serial one is excluding serial used for making beer. So serial that goes for a production purpose, or we can say for producing beer, that one is excluded from here. Otherwise, this serial are included here. So this particular information will not be needed. So I'm deleting this one. Here one is here information unit we are not going to use. So I'm deleting this one here also. We are having a value. So this one is for serial. And again the rest two informations we are not going to use. So I'm not deleting this one. So what informations you are going to use from this particular file? That one is country code, country, year. The year code and year are same, so I'm deleting year code, year and serial. Save this one. This one is meet file, so let me close this one. So this one is our serial. So I'm saving this one again as a Excel file in the same folder. So this one becomes serial. Save serial, save. Close this one. Opening is data again, and now I'm going to import serial variable onto the data. So serial one is here. Opening first as a first row as a variable name. Okay. Now I having all information given in a serial Excel file and going to save this particular data as a serial data. And again here you are having a longitudinal data, so no need to convert this one into any other format. Because for a panel you are going to use longitudinal data only. So now you are having a serial data file and meet data file. So if you are working with the serial data file and want to bring a meet informations here, so for that we need to merge serial and meet data file. So now we are working with the serial data file. So serial data file one is our master data file. So we import meet informations from meet data set for using merge command. So we merge 1:1. Then after country code is common in both data file and year information one is common in both data file. So we use that using meet. Look here, the data set has been fully matched. So we are having a 8,622 observations now. And look here in a variable window. Now we are having a both serial and meat informations together in a one data set. You may save this particular data set as serial meat. So serial meat, and drop this merge variable which has been generated, save, replace. Now we need to bring GDP information here. So for that, let's open GDP dataset. So again, I go on to my folder where I save all these data and opening GDP Excel file. So in that, we are having our data set in a this format. Okay, I think the file I shared with you, that one is the different one. In that, you will get some non-numeric information in all these blank columns. So here we can see the some blank columns or blank cells we can see. So you are here, you are having a many blank cells, particularly before 1990 period. So there is no indications given here for before 1990 period. But I think the data I have shared within that data for all these cells, you are having a non-numeric value. So remember this, for that data set, first we remove that non-numeric value, or we can do one thing. Since non-numeric value is irrelevant for us, so first we delete that. So let's delete this one. Okay. So we'll now you are having a data set since 1990 till 2019. Here you are having a indicator name. So remember this one. This one is the GDP per capita measured in P50, and this one is a current international dollar. So this one is the real GDP. So remove this one. We can remove this one also. Data source is World Bank, and it was last updated on 1st July. So we can remove this one also. But you must keep this country name and country code. So country name you can rename country, and this should become a country code. Country code. Okay, this become a country code. Okay. Country code. So rename this one. Let's say that this one is the country code 1. And or you can say for identifying this one is the World Bank country code. Image this image and country. Okay, for timing rename this one is country name. Earlier you are having a country name as a country variable in a FAO data set. Here I renaming just to make sure that we will compare this particular data with the FAO data set when you have all these variable at a common place. So look here, you are having a data in a wide form data. Okay. So here you first observation one is for country name, country code and years, and the rest are for different cross sectional unit for different years. So what we do before importing it onto this data, we rename our years. So we rename, in this one is the GDP data. So in a prefix, you use GDP. So let's suppose that this one become small letter set as a GDP. 1990 we also make as a GDP. So the first one become GDP 1990. The second one become GDP 1991, and after having that, you scroll that one up to 2019. So we renamed year as a GDP 1990, GDP 1991, GDP 1992, and so on. I'm going to save this one. Now I'm going to open Stata again and going to import that World Bank data file onto the Stata. So import Excel file and browse this one. This one is that data. Select that one. First row as a variable name. So I selected that one and OK. So look here. Now we have gotten the data onto this data, but that looks like this. And when I browse this one, this looks like this, as it looks like on the Excel file. So first you are having a country name, then country code, then year information. So this one is wide form data set. For merging it to the other data file, we require to reshape this particular wide form data set to the long form data set, and for that you use this reshape command, RESHAPE, reshape. Then we write our variable name, which one is GDP here, and by this I prefixed all year variable. So GDP, then I put a comma. In I case, I type this country code things, country code underscore World Bank, then bracket close, then J, and then year, and then after I enter. So it's showing that in the reshape command that you type, you omitted the word wide. Okay. So I made an error. I didn't specify it to what format I want to convert this particular data set. So since this one is the wide format data set, and I want to convert this one into a long format, so I type here long. That one is a longitudinal format, and then enter this command. So when I enter this command, look there, data set has been converted into the longitudinal format. So now you can see the data set. We are having a country information first, then after year in a sequence starting with the 1990, and then GDP information. See, everything converted into the longitudinal format. So now we are having a longitudinal form data set. Save this one is save GDP variable. So now it is become a GDP. Now we are having a file of GDP data file of GDP serial meet I merge. So one data file you are having a serial meet data file, and other data file one is GDP data file. Now look, both of the data file, here you are having country code in a non-numeric form. Look here, the country code is here in a non-numeric form. Here you are for Aruba country, the country code is ABW. For Afghanistan, country code is AFG, and so on. So I'm closing this one. In a serial meet case, if I serial meet, so here you are having a country code in a numeric form, 1, 2, 3, and so on. So Armenia, so Armenia, what you are having? You are having a country code 1, and for Angola, you are having a 7, and so on. So the question arises, how do we merge these two different source data files? So the one way we can use country command that I have shared with you, that PDF file that I shared with you. The problem of using that PDF file is that, or let me open that one first. So this PDF file I shared with you. So country command PDF file, and this particular command you can use and when we require to cross-country data file from multiple sources. And here some data sets, data source name are given, and the character and numeric data name character and data name numeric codes are given. So World Bank, look here, since you are using the World Bank, so World Bank data are coded, particularly country are coded in a ISO 3C format. Okay. Payroll table is also provided by the World Bank, so it has having a same coding. IMF one is having a IMF provide IMFN. So, so particular document is helpful. We merge IMF and World Bank data file or IMF source data file, which are mentioned here. But look here in this particular document, stat is nowhere mentioned. That means using this particular document, we can't merge FAO and World Bank data file. So the question arises, what then we do next? So, of course, there is a solution for it. And the solutions lie again a different document that we get from FAO website only. So, I remember when I working with this particular data file, okay, I do not know whether that data file were then available on FAO state or not. But since I did not know about that particular data file, I did all the works in Excel. So I bring all the data file onto Excel, try to and identify data file and World Bank data file. Then I try to match the years variable. So suppose that deleted that one. Let's suppose that I'm working with the Armenia, and Armenia having a not having a data set and a data value for a particular year, and World Bank having a data of that particular year. So of course, for a balance panel data set, Armenia country become irrelevant for me, so I deleted that one. So I did an exercise like this that took a lot of time of mine, and so after doing all this exercise, I reduced the 76 one, keeping other, and making up things like this. But when I working with the uh, second time on with the updated data sets, I fortunately got that documents which deals and with the help of that we can do merging of different source data files. Okay. So that data file is still there in FO state. Yesterday I searched about that data file and I found that one. So I missed to record the link URL link of that particular document. But when we search on the Google, we'll be able to get that uh, document. Apart from that, I also encountered with another document, which one is provided by, I think, United Nations, and that deals with the updated formats of different data source data file. So, like earlier, World Bank used to have ISO 3 format, ISO and 3 format. Now they have updated and they are giving the data set in a new format. So I didn't read about those in detail, but when you get anything like that, where you will get a one country data set entirely a new form, so do not worry about that. Just do a Google and we will get a similar document, okay, or document relating to with that, and with the help of that we can merge different data source data. So that one is for your information. The data file one is this one, which I named here country code. So let me open that. This one. So look here. Here we are having an information of short name, which one is basically a country name, then the official name of that country, and this one is the country code, coded in a different ways. So ISO 318, I told you, for a World Bank data set. ISO 218, and you need to check the detail. I haven't checked the detail, but here you are having a state code, country code also. And since for today work, we need only FO stat code and SO 3 code. So once you have these two informations in our common data file, both ISO 3 and FO stat, we are able to merge FO stat data set with the World Bank data set or vice versa. So let's do that. So this one is again, let's keep this one is short name only. So rename this one is short name. This one become official name. Official name. Though official name information you do not require going to use, but I'm just keeping so that we'll have particular variable in our data set also. So like this. So this I save this one, and I am going to import this data onto this data. So I open this one, clear, then I import this particular Excel data file. So I go on to import Excel, browse this one, This one is country code. So open, and this one is variable name. Okay. So now we are having all those data onto its data. Save this one as a code. Save. What next step is? So next step is here. Either you bring FAO data first here or World Bank data set first. So let's import World Bank data set first. So for what we need to do, merge 1:1. Okay. So before doing that, we need to ensure that the common variable that we are going to use here for merging our data set must having a common name. So like in here you are going to use country code variable and year variable for importing and merging the data set. So and look here you do not having a year variable, sorry, but here you do not have year variable. Here what we are having, here only we are having a country code variable. So let's first merge GDP. In a case of GDP file, if I use GDP, so here you are having a country code variable, and in a code with data file, we are having a World Bank code as a name ISO 3. This one I am talking about, this one ISO. Here you are having a ISO 3. So need to rename this one. So this one is the short name ISO 3. So let's leave this one as it is. What we are going to do, I am going to rename GDP country code in this. So rename GDP. So country code World Bank as a ISO 3. So ISO IS, that would be O. This become ISO 3. Save this one. Now I'm going to bring merge 1:1. I'm importing code data file information here. Merge into one ISO 3 using code. Say कि ISO 3 does not uniquely identify observation in a master data. So no new problem. So I told you, when we actually work with this data management things, we encounter with many problems, and that give us an in-hand experience what kind of problem we actually face when we try to make a panel data file. So the new problem arises here. A variable ISO 3 does not uniquely identify observation in the master data file. And of course, it is because in a master data file, we are having a multiple informations of a particular country, because those particular country information given over a period of time, or in a using data file, you are having only one information for a one country data file. So if I use this one M:1, because in a master data file you are having a multiple information. So let's see how it works. If I enter, it works. So now you are having a both the data file information. So ISO 3.1 is here. You are having a year variable, country name variable, and so on. And along with also you are having a FAO code. So since I am not going to use apart from ISO 3 and FO state variable. So I would like to delete rest of the information from the data set here. So I'm deleting ISO 2, I am deleting ISN, UNDP, GAUL, and also merge. So I deleted the variables which is no longer required and save this one as a GDP or replace GDP. So instead of saving into a new data file, so I replace GDP1. So save GDP replace.
Sir,
Yes.
can you explain different commands for merge? Like what does M is to M1 and 1 is to M and 1 is to 1? Like what are the difference between these commands in merge?
So okay, best way to learn about that, to type help merge. This window pop up, click on this blue icon. A PDF file will be open like this, and here details regarding that is given. Okay. So look here. Okay, this one is given in okay. Okay, I'm explaining you about that briefly. Let me open the whiteboard. So let's suppose that here, so these two set you are having. So let's consider these are the two sets, and this one is the household data file, and this one is the individual data file. Individual data file. Okay. So we know, so this dot represent one household. So here you are having a 4 dot. Sorry, let me make it circle. So here, sir, each circle and a small circle belong to one household. Let's make it big dot. And since one household having a more than one member, let's go with that assumption. So it might be that the first household having 2 members. Okay, second household. So this one belongs to the first household. Second household having a 3 member, something like that. Third household having a only 1 member. So this one is for third household, and fourth household having a 4 member. So, and in a household data file, you are having information of household characteristics like family size information, land information, social category information, and so on. In an individual data file, generally what you get age, gender, educational qualification, so education, and so on. Also experience. Okay. And if you want to merge these two data files, so here in a first data file, you are having only one observation for a one household. In an individual data file, you are having a multiple information belonging to one household. So when we merge household to the individual data file, and we work and we begin working with the household data file. So here present data file, which is household data file, which we call the master data file also, master data file, and you want to import information given in an individual data file onto a master data file. So in that case, you type command merge is to M, because we are merging one household, one individual data file, into a master data file. So in that case, you type command merge 1 is to M, because we are merging one household, one individual data file. So in that case, you type command merge 1 is to M, because we are merging one household, one individual data file. So in that case, you type command merge 1 is to M, because we are merging one component with the many components. So you are merging this particular unit, the first household unit information with a different individual. So this information merge with this also merge with this. Okay. So you are importing this one to this one here, or vice versa you can do. Since our master data file one is the household data file, so we are using 1:m. If master data file one is this one, individual data file, then for the same work we use m:1. Merge m:1. Are you getting me? So that's why and in our case, since we started working with the GDP data file, which we are having a multiple information of a particular country, so I used m:1. By using data file having only one unit record for each cross-section unit. 1:1 we can use when you are having only one observation for each cross-sectional unit. One unique observation I am talking about. So let's suppose that in a same case we are having a two data file, both are household data file. So this one is also household data file. This one is also household data file, but having a different information. So let's suppose that first two information, which one is the family size and land informations are given in one data file, and rest two information, social category and religion information are given in another data file. Now if you want to bring all information, family size, land information, social category, religion information into one data file, so in that case you use merge 1:1, because you are merging one element with the another element, and here you are using merging, and you are combining the information of household to household. Here you are combining information of household with the individual data. So this here you can use 1:1. So any doubt?
No, sir. Thank you.
So actually when you work with the NSSO data set, there will encounter with a whole concept are this much only. More about this concept you can read from the Stata document. Practical experience you will get when we actually work with such kind of problem, and particularly when we work with the NSSO data file, we will encounter many different variant of this particular problem. Because as I told you, this one is the initial command, and after this we need to identify a and that's called a primary variable. Okay. Primary variable through which we merge one data file with the another data file. So NSSO comes with a document, and that document indicate us which one you can use as a primary key variable. So with working with the consumption expenditure, employment survey, there are 5 variables which we directly use for merging particularly household to the individual data file. But more complexity arises when you work with the consumer expenditure data file, and you want to bring one commodity information into, and you want to merge at a commodity level instead of at a household and individual data file level. Or when we work with the digestibility survey, which one is the special survey conducted by SSO, so there are different kind of digestibility. And then you want to merge the two kind of divisibility, so first you need to identify that divisibility variable. Okay, and of course to which data file that information is given, so that you merge a particular in those particular data file. So the complexity are there. So many people who generally know these basic commands, okay, find lot of difficulty when we actually try to merge those data files. So that's why I initially told you you will learn a lot when you work with a survey data, an SSO survey data file, and that would be really helpful you in future. Where I were. So okay, so I got this one GDP. It's already 4 o'clock, so let me complete this panel data file, then we stop, and rest we do in the next class. So GDP informations are here. Now I'm going to bring serial and meet information here also. And look here, now we are having multiple information for a one cross-sectional unit. So for importing data, yes, when you would like to say something. Okay. So I use merge, MER merge 1:1. Then country. Oh no. So since again I'm going to use FO stat variable for merging. So here it has named as FO stat. So first I rename this one, because in a FO, in a serial made data set, country code there as a country code variable name. I rename here FO stat with the country code. And now I use merge 1:1 country code here, because here is again a common variable, using serial mean. So here it says variables country code here do not uniquely identify observation in master data file. So master data file one is this one. I is showing so. Okay. Look here, this one is another challenge. Data sets look like something like this. That means you are having a country code, which one is here in a numeric form, and then after you are having a year here, which will start with the 1990. So the problem you are facing right now, which one is saying here, variables country code year do not uniquely identify observation in a master data file. So first we check why it is showing it. Basically, this particular problem arises when we are having a duplicate observations for a particular cross-sectional unit. So let's check that. And for checking that, I'm going to generate a unique identity for each observation. So that means if a particular country having a value for a particular year, so for that I'm going to generate a unique number, and that I generate usingegen command. Soegen, I am generating ID here, ID equal to concatenate command I am going to use concatenate. So in short form it's called concat, and using country code and year information. Country code is this one. RI mistake. So this one. Now I look here in the variable window, ID is generated. Now I'm going to check whether this ID having a duplicate information, or is there any duplicate information for this particular ID. So for that I use this code book command. So for code book ID, and look here, it is saying that the unique value is 5823, but you are having a 7923 observation. That means you are having a many duplicate observation. So what to do for that? So of course we require to remove or drop duplicate observation. But again questions arises, or may curious to know which are those duplicate observation. So for that there is a particular command which I am not getting right now. So take a help of Stata, type duplicate. So this report duplicates command one is this one. So report duplicates report. Use this particular command. Get a various options. Duplicates report. You can report this. I'm using this particular command. So let me check, just for check. In our data set, you are having around 2000 duplicate observations. So, okay, it says that duplicate in terms of all observation, it is 7923. It having a only copy one. So duplicate report ID. Okay, look here. It says 5793 having only one observation, and 2113 having a duplicate observation. Surplus value you are having for that is 21, and number of copies there is 71 observations. So but it might be there is a one ID which having a 71 duplicate observations. Again there is a Stata command to identify that. For that I think duplicate tab generate duplicate. This command one is this one, and duplicate list. So when I type this one, this duplicate in terms of our observation, duplicate ID. So look this one, the observation given here, group ID given here. ID 1991 having a duplicate observation. ID 1991, 93. So these are the duplicate observations. Okay, these are the options, various options by which we can get to know more about the duplicate variable. But like this, if I type this one, duplicate, so new duplicate variable has been generated. So if you see this one, you can see that duplicate 01 is having a unique observation. Okay, so let before going into the details, let's write off this duplicate observation, and for that a particular command is drop duplicates ID force, if I remember correctly. Let me use this one, otherwise I take a help of this data. Variable duplicates not found, so ID duplicates force. This one is again, let's see here, duplicate drop. Look, this one is the information. Duplicate drop. So this one is duplicate drop. I think variable name required and force. Okay, look. Now the duplicate. I have dropped here duplicate observations. So 2100 observations deleted because those having a duplicate observations. So again, I use codebook ID and see here. Now we are having no duplicate observation. Save this one. Save replace. Save replace. And let's try to merge again using that command merge country code here using serial bit. And when I did that, let's see now data has been merged. So data is merged, and now we are having a match data of 300, 900, 11 observation. Not matched are 6,622. Why you haven't gotten have gotten, sorry, not matched? Because let's save this one first, then after I tell you why. So I'm saving this one in total serial, and let's go on to the serial mid data set. So use serial mid data set, and have here, or you can say describe here, summarize here. So in a air case here you have seen a serial mid data set starting with the 1961 and GDP data starting with the 1990. So because of in a serial mid data set you are having a more number of years value. When we merge our data set, not matched data, not matched number of observation are so high. So that's not an problem at right now. So clear this one. Use total serial. Which one is merge data set? Drop merge from left merge. So now we are having a all variable informations in a common data file. And now you can use, now you can say our important variable one is country code, ISO 3 and FO stat. FO stat one is the country code now and country name. This one is the just to let you ensure you have merged correctly. So look here in a FO data set, the Armenia country is coded as 1, which one is a numeric code, and in a World Bank data set it is having a ARM and so on. So for Algeria, country code is FO country code is 4 and ISO 3 is DGA and so on. So this shows us you have merged our data set correctly. So now you are having all important information. Since you are going to work with the balance panel data, so required to make this data set as a balance panel data set. Now in a present format, we are having an unbalanced panel data set. So as I told you earlier, when we declare our data set as a panel data set using xtset command, so xtset, then after you use country code because that one is our cross-sectional unit and air. It shows here the panel variable one is unbalanced panel. So we need to convert this unbalanced panel to the balanced panel. And for that there is a command which we call xt balance command. So I'm taking a help of Stata because I didn't remember that one. So help xt balance, and look here, when you go into the last, we use this particular command xt range, then after date. So I'm explaining this command to you. So xt balance one is the command, then after you put a data range. So if you want to keep your data, our data set range from 1960 to 2019, and missing all option here. If any missing observations will be automatically deleted while making balance panel data set. So when I enter this one, it says a range is invalid. Why it's so? Because instead of typing 1916, I typed 960. So deleted this one. It say okay. It say 6,766 observation deleted because those had missing observation, and 3 deleted because it is out of range. So now we check our data set using the same xt set id command. The xt set id, sorry, country code here. Now again you are having a unbalanced panel. It should be not, probably it is written there because it is balanced. So let's set xt set describe command. So describe xt describe command. So so this one is the description of our data set. Delta 1 unit span 24 year. So 166 cross-sectional unit are having for 24 year data set. $97. Country code is again it's in a, let me count this one, 3,700 display. You can check this one also, and you are having 166. 166 multiplied by 24, 319.84. And data set you are having 3,765. It is still unbalanced. So if I type this command, though this command give us unbalanced, so let's suppose that instead of 1990 I type, then count. This command generally give us balance panel data set. Either I am making a mistake, but I think we need to check code book. Let me check. Sorry, code book, country ID, country code is in our case. Country code. I think I have tired. When we start making lots of mistakes, that means we need a break. So let's offer the here unique value one is 166. Okay, that's okay. That means you are having a 166 cross-sectional unit. Similarly, we do for code book air. So air you are having a 24. 24-year data. And for a balanced panel, we required number of observations, that would be 166 multiplied by 4, which coming out 3,984. But we are having only 3,765 observations. So in a data sense, okay. So again here you are having a no missing observations, but you are having a missing value for some years. Okay. So theoretically our data set is not a balanced panel data set. So we require to identify that, and once we remove that, okay, we proceed again ahead with the panel data estimation. So let's stop here. Removing for that removing, I think I have to think which year and data set is missing from our data set, for which cross sectional unit. But generally XT balance give us balanced panel data set. Why I'm not getting this time? I think when I need to check that. Okay. So we'll do that in the next class. So you start with that. Meanwhile, you can also try by yourself for making a panel data set. Now at this stage, it is not tough. You just need to identify those cross-sectional units which having a missing values for some missing years, and we need to remove that. That's much only. So that's the case. So rest you do in the next. Any doubt? Hello? Can you hear me? Hello? Hello? Can you hear me? Oh, cannot hear. So now, can you hear me now?